Hello, welcome to my channel. This is my first video that I'm going to do about some old hardware renovation, you could call it. In this particular case, it is a, I don't know if you can make that out, it's a Sinclair QL power supply. Now these are apparently quite hard to get now, but I have one for my Sinclair QL. And what I'm going to do to this is I'm going to change the capacitors in here, because I believe they're probably, after 30 or so years, they're probably dried out. It's highly unlikely that they haven't dried out. Dry capacitors will not give a visual clue, so there'll be no bulging or other clue. Sometimes you may see other symptoms of a bad capacitor, like it might have leaked, or as aforementioned, it may bulge. But often in most of the old gear that I have, when I look at the capacitors, they look fine, but there's just no way that after 30 years that a lot of that electrolyte won't have just dried out, which means they won't be doing their job properly. They won't be filtering the power correctly for your device, and when your device is getting on in years, you really want the power getting through there to be filtered correctly. I'll possibly be trying to fit a regulator to the low voltage output on this at a later date, but at this stage I'm just going to replace the two capacitors, and what I've got is these capacitors here. The ones in there, you can see inside the QL power supply, there's two in there. They are 3,300 UF capacitors. The only ones I could get locally without having to order online were 4,700 UF, same voltage, 16 volts. These ones are low ESR, which means they have a lower resistance. They can take higher temperatures. Most of these old power supplies, or a lot of them, certainly had no ventilation at all. This has absolutely no ventilation at all. So I figure a capacitor that can take higher temperatures is the better one to fit in here. Generally in a power supply, having more capacitance isn't generally a problem. Just may take a bit longer to charge up, but in the simple scheme of things, it should be okay. There is a thyristor on here, which is this little, you can barely see it, this little component there. It looks a lot like a transistor, but it's called a thyristor. I believe that works okay at the moment, so I'm going to leave that as is, but certainly with the capacitors I know that they will be dried out. So I haven't seen any other videos on YouTube yet of someone having a look at a Sinclair QL power supply, so here's the first one. It's got this strange, looks like exercise book paper that's been stuck on the top, and it looks like it's been done from the factory. I don't know. I certainly can't think of why someone would open it up to do that, but I don't know. Who knows? It's 30 years. It doesn't appear to have been opened before. But anyway, let's get to it. I'm going to remove these capacitors and put my new ones in. I don't have my QL here with me, but I will possibly show this working at a later date, but I'm just really wanting to show everybody what the QL power supply looks like and what it's like to change the capacitors on them. So I don't have a fancy studio here, I'm just doing this at the table, so I'm just going to angle the camera down and try and show you guys what I'm doing. Right, I'll just put this down here. Forgive the cable spaghetti, I'll try and move it away a bit. Right, okay, so take it out of the, should just remove the cables. They just pop out from the side, and then we can just lift this out. Now I've previously disassembled this to see what it was, the procedure. So what you've got to do here is remove this screw. There's a little cutout in the heatsink to do just that. So I'll remove that screw. It has a little nut on the back side of it. That just gives that thyristor a place to vent its heat. It's a rather large heatsink, so I imagine it probably gets quite hot, but I'm sure that heatsink was plenty for the job. It also backs onto those capacitors as well, so it gives them a bit of cooling, I imagine. Right, so in here you can see that they've put some sort of wrapping around the capacitors. I'm not sure what that's for. Hold them together, I guess. Just take that off. It's just like tape with like this old fuzziness on it. Anyway, let's remove that. Okay. I can see one of these caps actually has a dent in the side. It's one way you can kind of tell if well, once you've removed a capacitor, if it's a bit done, is they will feel a bit too light. These ones, hard to tell. Right, so just having a look at this, I'm trying to work out where they. Okay. Well, they haven't made these easy to replace. The whole. You look at the. If you look at the back of this board here, you'll see that the actual. You can't really see very well, but under there, the whole transformer, the transformer leads has been soldered right through the board. So yes, it's not going to come off easily. So what I think I'm going to do is I'm going to cut the legs on these capacitors and simply join my new capacitors, solder them to the legs that are there, because on the reverse side of that, on the reverse side, see that very well. On the reverse side, these capacitor legs, they just disappear into the board. I'm not really sure how they've done that, but anyway, let's do it. So we will take note of the polarity. So yeah, it looks like on the inner leg of both of these capacitors, the inner leg is the this is the one that's is a leg that's marked, and I can see these capacitors are actually standard 85 centigrade capacitors. So these are actually inferior quality to the ones that I'm going to put in there. So I'll just cut these off, leave a bit of leg to solder onto. Leg. I'll just do these one at a time. There's one. Doesn't feel too bad. So now what I'm going to do is I want to cut these to fit, to solder onto those existing legs. Just cut them off a bit to start with. This is going to be quite difficult, I think. Some way of holding that. This is where I need a third hand. Oh, I know what I'll do. Soldering iron won't stretch very far. Try and solder the same polarity leg onto here. I'm going to use a bolted top to hold that in place. It doesn't want to stay there. It's not bad. First leg was the hardest. The second leg. Blob of solder there. Bit blobby. Bad. Not fantastic. Bad. That's one. That's one done there. The new one there. Sitting a bit higher than I'd like, but could probably bend that down a little bit. second capacitor. I'm remembering that they had the marked leg facing the inner side on this. Once again, the first leg is going to be the hardest. Hardest by some degree. Practice makes perfect. I went on alright. The second one. There is no electrically static sensitive. There is no static sensitive devices on this power supply, so right. I'll just put a bit more on the other one. Right. Not bad. Those first one I might just put a bit more solder on it. One of these legs. Reasonably happy with that. I'll just put some, put this original tape back around here. It's pretty fuzzy. Okay. Might just get some more electrical tape. And I can't find a knife. I can't find a pair of scissors for my tape. That'll do. The idea of the tape is to separate it from those on that board. I can see this is not going to be long enough. Twice as long, I think. Obscure the tops of those capacitors with tape. The tape is a bit wide. Right. Put another piece around the back there because I think insulate it from those pins. Haven't been trimmed very well actually in the factory. Right. You see I've replaced, I can't really see them now, but there's the two new capacitors in there. 4700 UF 16 volt low ESR, and I've just, because of the nature of the circuit board, I couldn't really desolder them, so I've cut the legs off the old ones and soldered on the new legs for the new capacitors, taking into account the polarity. The inner two legs there are the marked polarity legs for the capacitors. Someone just came in. Right. Oh. Now we'll just put this back together. Heatsink. This is quite fiddly. The heatsink with a washer has to go through the board, the heatsink, the thyristor. Yeah, it is quite fiddly. Just hold that nut with your finger back and tighten it up nice and tight. Yeah. Right. Certainly these capacitors are not going to get as warm in operation, so this power supply in general should be, I would think, will be possibly running a bit cooler. I'd like to think so. Put it back into its shell. It'll only go one way because of the cutouts on the plastic base. And it's fitting in there just fine, which is good. Two cables pushed back in there. And the top for the power supply, it'll only go on one way. Right, yeah, so it goes on that way. Cable coming out the bottom, cable coming out the left hand side, and the Sinclair logo at the top. That's how it goes on. Screw it up. So feel free to comment. This is my first renovation video, so to speak. Hopefully in time I'll be able to improve the presentation, but at least you guys will, out there with this actual Sinclair power supply, will have some idea of what's inside there and what you're going to be dealing with to change the capacitors. So I hope that's useful, and yeah, feel free to comment and let me know what you think.